Hi there, and welcome to the practice set for solutions and x-intercepts. Give this video a thumbs up if you find it helpful and subscribe to the channel for more math help. As always, pause the video to try these problems on your own and then come back to check your work. Okay, so what we're doing in this problem set is we are solving the equations algebraically, and then we're going to use graphs as a way of checking our work. So for this first problem, what might help, you don't have to do this, but this is what I was taught to do, is instead of that minus sign there, go ahead and write plus a negative. And the reason why you might want to do that is because it reminds you that you are distributing a -2. I hear from my students all the time, how did the 1 become negative? How did that become negative? And it's because that minus sign goes with the 2. It is signifying that we are adding a negative number there, and the negative number is what we are distributing. So in this first step here, we'll go ahead and do that distribution. So bring down the 4x. -2 times x is -2x, and -2 times 1 is -2. Combining our like terms, 4x plus -2x is 2x. And then isolating the x, we will add 2 to both sides of the equal sign. -2 plus 2 is 0, which is why those cancel out. And 0 plus 2 is 2. And then this is multiplication. So we'll divide. 2 divided by 2 is 1. And well, then we have 1 on the other side there. And 1x is simply an x, and so we don't typically write the 1 there. So we know that the solution to this problem is x equals 1. So the other challenge here, though, is to check that answer by graphing. And to do that, we're going to back up to this line right here, where we have 2x plus -2 equals 0. And this is the piece in the lesson that we talked about. And if you haven't checked out the lesson, please do that. I will try to remember to link that if you're like, wait a minute, I don't remember a lesson. Snap, is we are going to set that 0 equal to y. And so in essence, so we've got a y there, and then you might want to write it like this. This is like personal preference here. We just typically like to have the y on the left-hand side, but it doesn't really matter. And what we're doing when we're doing that, when we say y is equal to 0, we are fixating on the x-axis there, because my computer just made a really strange sound, but it looks like everything's recording, so very weird. Every single point on that x-axis has a y coordinate of 0, so it's something, comma, 0. And so in that step, we are fixating or highlighting the x-axis. So now we have a line. The y-intercept is -2, so I'm going to go ahead and plot a dot at y equals -2. And then the slope here, okay, so this is our b value, which is 0, -2. And then this is my slope. And remember, if slope is 2, it's rise over run. And so I can count from my y-intercept up 2 and over 1. So 2 over 1, up 2 over 1. I'm going to do that a couple times just to make sure that this line there, 2 over 1. We can go ahead and connect that. And what we're looking for specifically is the x-intercept, which we can see is right there at the point, does not want me to mark it up, at the point 1, 0. And so what that point signifies is when y is equal to 0, x is equal to 1. Oh, look. And then we get x is equal to 1, which matches our answer over here. Okay, and so that works as our check. Next problem. All right, so this one has an x on both sides, and so we want to, well, first we'd simplify everything on each side of the equal sign, but you cannot simplify 5x minus 2 or 2x minus 14. So we're going to try to get all the x's consolidated on one side. So I can do that by subtracting 2x or adding negative 2x from both sides. 5x minus 2x is 3x. And then remember this, okay, so this is a common spot. That minus sign goes with the 14, and so when you subtract the x out of there, you still have a negative 14, and this is another situation where it might be easier to write plus negative 14, okay? It's just like a reminder that, hey, that negative goes with the 14 there. Now we are going to isolate the x, so we'll do that by adding 2 to both sides. Negative 2 plus 2 is 0, leaving me with 3x. Negative 14 plus 2 is negative 12. This is multiplication, so we'll undo that by dividing. 3 divided by 3 is 1, and negative 12 divided by 3 is negative 4. All right, now to check this by graphing, we are going to back up a little ways. We're going to back up right to this step here. And instead of, drop my negative sign out of there. There we go. Instead of adding 2 to both sides, we are going to perform this step, which is set both sides equal to 0, or set one side equal to 0. Can't set both sides equal to 0. Good luck with that. And we'll do that by adding 14 to both sides. So here on the left, we'll have negative 2 plus 14, which is 12, and negative 14 plus 14 is 0. And now we're going to do that little switcheroo for graphing. We're going to say that the 0 is equal to y, or if you'd prefer to write it the other way, you can go ahead and write it the other way. So now let's go ahead and graph that. My y-intercept there is the point 0, 12. So that's going to be right there on my graph. And there we've got the slope is 3, which is 3 over 1. So there's my rise over run. Now, if I count up 3, 1, 2, 3 over 1, 3. If you've got a ruler, this will probably work out okay. But it's going to be really easy for my line to drift. And I know I'm looking for the x-intercept, so I'm looking for something down here. And if I don't line my ruler up perfectly there, I might drift. So what I'm going to do is do this. I'm going to, instead of thinking of it as positive 3 over positive 1, I'm going to think negative 3 over negative 1, because that's also equal to 3. So I'm going to count down 3 and left 1. So going down 1, 2, 3, left 1, down 1, 2, 3, left 1, 2, 3. Okay. Down 1, 2, 3, left 1. Down 1, 2, 3, left 1. And that's the point that I'm looking for. 1, 2, 3, left 1 was that x-intercept. So once I feel pretty good about having that, we'll go ahead and put the line in there. And there's my x-intercept. I meant to change the color. There it goes. Okay. And so there's the point negative 4, 0. And once again, if y is equal to 0, then x must be negative 4. And it is our check for our algebra work. So the x-intercept does correspond with the solution. One more problem. So in this one, we do have some simplification to do on each side. So if you recall from learning how to solve equations, we're going to keep each side of the equal sign separate from the other side until we're done simplifying. So distributing the 4 here, I'll have 4x. And now you could do minus 4. Or you might say, let's go ahead and make all that a plus negative, whatever you like. That is equal to, and here we're going to distribute the 5. So that would be minus 15, or if you prefer, plus a negative 15, and then bring down the plus 8. And then I do have some like terms right there. So I am going to copy everything down here. So you might feel like, oh, why are you doing that? Is -7, -15 plus 8 is -7, because that's good math form. Okay, so you don't just like kind of wander and off to the side and do a little bit of scratch work. Like everything comes down line by line. Now I have, what do I have here? I have some x's I can consolidate. So now we're actually going to start moving stuff around. I have 4x here. I'm going to subtract 4x. 4x minus 4x is 0, leaving me with the -4. And 5x minus 4x is 1x. And we have the plus -7. I would undo that by adding 7. So we'll add 7 to both sides. -4 plus 7 is 3. And of course, 1 times x is x. And so my answer is x is equal to 3. I have 3 equals x. If you'd like to flip it around, go for it. Now we're going to check that. So to check that, we're going to back up right here. We had -4 equals x, or 1x plus -7. And remember, when we're doing this, we're trying to get a 0 on one side. So I'm going to, instead of moving the -7 over to the other side by adding 7, I'm going to move the 4 here by adding 4. -4 plus 4 is 0. Of course, 1 times x is just x, and -7 plus 4 is -3. And here's our special little switcheroo. We're going to set y equal to 0, and so we'll be graphing that line instead. The y-intercept is 0, -3. So I'll go plot that. And then my slope here, okay, is the number 1. And so we could think of that as 1 over 1. And so I'm going to count up 1 over 1, up 1 over 1, up 1 over 1, up 1 over 1, up 1 over 1. Okay, and enough to know where that y-intercept is, or x-intercept is. And there's my x-intercept right there at the point 3, 0. So we are saying when y is equal to 0, then x is equal to 3. And for the third time out of the 3 times, our graph confirms what our algebra says. Now you might be thinking, well, this seems like a really inefficient way of checking your work. Yes, it is, and it's not very common. If you watch the lesson video for this, I get into why this is a useful concept, and it really, more than dealing with lines, has to do with much more complicated equations that have a very difficult algebraic solution, or sometimes an impossible, like they're impossible to solve algebraically. And so in those cases, having a graph is really useful. It's also very useful if you have access to a graphing utility like a graphing calculator or the online calculator Desmos or some equivalent of that, where graphing these things would actually be pretty easy to do. So just for checking the solution to a line, probably not, but just keep in mind it's the concept that's important, and it's just one of those little things. You file it away in your back pocket for future use should you need it. All right, don't forget, give this video a like if you found it helpful, subscribe to the channel for more math help, and drop a comment or a question below and let me know what you think. I will see you in the next one.